Welcome to lesson 38. We're going to be solving 3 by 3 linear systems, which means that we're going to have 3 different equations. They have to be different, of course, and 3 different variables, 3 different unknowns to solve for, in this case x, y, and z. Now first I'm just going to kind of show you the way it works, and then we can sort of look back and say what I just do. So the first thing I like to do, just to help me keep track of myself, is to say, okay, I'm calling that equation 1, I'm calling that equation 2, I'm calling that equation 3. Now I want to use the addition method a lot, which means add 2 equations, make something go away. If you look at these bottom 2 equations, notice the z's, they're ready to go here, right? They're ready to disappear. So I'm just going to write this. I'm going to say add equation 2 plus equation 3. And I'll just do that. I'll just look here, right? Add your like terms. 8x and 10x, 8x and 2x makes a 10x. Add these. Negative 4y, negative 5y makes a negative 9y. The z's go poof. That was what we liked. And then add the negative 7 and the 0. You get, of course, a negative 7. So let's clear this off. We just built ourselves another equation. I'm going to call it equation 4. And what's nice is this equation doesn't have any z in it, so in some sense we're making progress, I guess. Now I want to do that same move, but with 2 different equations. In other words, I want to make z go away again, but I got to use different equations. So what do you say we use these 2 equations, because they're also ready to go. If you add equations 1 and 3, the z's will disappear. So that's the next thing I'm going to do. I'm going to just write it to myself. I'm adding equation 1 plus equation 3. And what does that give me? Well, the 2x and the 8x. Gives me a 10x again. That's interesting. Okay, the 3y and the negative 5y gives me a negative 2y. Okay. Again, the z's are going poof. That's what we like. And then the 14 and the 0 is adding up to a 14. So there's my 5th equation. So I'm going to try to clear this up a little bit so it doesn't look so nasty. Okay, cool. So I got rid of z, and then I got rid of z from a different pair of equations. Now look what we got here. You've got an equation with x and y. You've got an equation with x and y. What I like to say is that we have extracted a 2 by 2 system. We have extracted a 2 by 2 from the given 3 by 3. So we started with a 3 by 3, but with a little bit of footwork. Now we've got a 2 by 2, and we know how to solve those. We've been doing this for homework for like over a week. So let's see now here. Let's just take a look at these 2 equations. Well, this one's got a 10x. This one's got a 10x. Be nice to make one of those a negative 10x, wouldn't it? So my instructions to myself are going to be, I'm going to say, let's take equation 4 and multiply it by negative 1. And then I'll add on to that equation 5. Now I'll just actually write this out this time. So I'm multiplying equation 4 by a negative 1. So 10x here becomes negative 10x. Negative 9y becomes plus 9y equals, and then the negative 7 becomes positive 7. Okay. Now I'm going to add equation 5 as is. So I'm copying this bottom equation now. 10x minus 2y equals 14. Can add these 2 equations together now. The x's go away. I got a 7y here. 14 and 7 is 21. Ooh, divide both sides by 7. We've got an answer. Y equals 3. Isn't this fun? Doing 2 by 2s is always fun, right? Let's finish this 2 by 2 because you know what? That's y. Let's go get x now. What do you say? What do you say? So I'm just gonna say I'm plugging this into, and it doesn't particularly matter which equation, but I'll plug it into 4. So equation 4, reading across here again. I got a 10x minus a 9y, but I know the y is 3, so I can put that in, equals a negative 7. And I can solve this up. So 10x, that makes a minus 27, equals negative 7. If I add 27 to both sides, negative 7 plus 27 is going to give me a 20. Divide both sides by 10. I've got x equals 2. Look at that. X equals 2. Y equals 3. I'm almost done. Now, don't forget, we got to solve for x, y, and z. Right? It's 3 equations, 3 unknowns. So how am I going to get z now? Well, I've got y. I've got x. I can plug those into any one of these equations. Doesn't matter which one, they'll all give you the same answer. Plug it into any of these equations and solve for z. So I'm just going to kind of say this way. I'm going to say now I'm going into plug in, maybe you put the word plug into equation 1. So equation 1, where is that? 2x plus 3y plus, I'm just going to write it here so I don't mess myself up. 2x plus 3y plus z equals 14. That is equation 1. Okay, 2 times, put the x in, the x is 2. 3 times, put the y in, the y is 3. We're solving for z here, equals 14. And you can see we're almost there. That's a 4, that's a 9, that's a z equals a 14. Those make a 13. Subtract 13 on both sides. Z is equal to 1. Cool. And so the solution to this 3 by 3 system is, it's a point. It's the point x equals 2, y equals 3, z equals 1. Doop, 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 doop. It's a point with an x and a y and a z coordinate. What's that mean? Well, see, these are not really lines anymore, because if you look at each of these equations, you've got an x-axis, you've got a y-axis, and you've got a z-axis. So imagine trying to plot that. It would actually be really hard, because you would have to have some kind of a 3D thing to plot in, some kind of a, I don't know how you would do that. Because you have to have an x-axis, you have to have a y-axis that's perpendicular to it, and then you have to have a z-axis that's perpendicular to both of them. These are not lines, these are like planes. You have to imagine like sheets of paper or something. But when we found this solution here, which is the coordinates of a point, x is 2, y is 3, z is 1, so that's, you have to try to imagine x is 2 is somewhere around here, right? Apparently we have like 3 sheets of paper that all happen to, I don't know how this would look, but the 3 sheets of paper actually all intersect at this one point. There's only one point where all these 3 planes, all these 3 sheets of paper intersect. So we're playing kind of a different ball game geometrically. They're not lines anymore. There's no way we're going to solve this by graphing, right? No, but that's okay, because we've got this addition method, very powerful. So looking back, again, the idea, you look at your 3 equations, you kind of try to figure out how can we extract a 2 by 2, which means add 2 equations, make a variable go away, add 2 different equations, make the same variable go away. That'll get you a 2 by 2 system. We know how to solve those. So you solve the 2 by 2, and then once you've got your 2 solutions, bring them up into any one of the original equations to get your third. That's the basic process. I hope you like it. I hope you're digging it. I have 2 more examples that I want to work through, and the next one is basically, it's just a little bit more involved, I guess. But I want to do this again just to make sure we're kind of getting the rhythm here. So, okay, there's my 3 equations. I'm going to call them equation 1, equation 2, equation 3. Now these 3 equations aren't quite as nice as what we were just dealing with. I mean, the other one, we had a plus c, we had a plus c, we had a minus c. It was very easy to make z's go away. When you're looking at this, though, you're like, what am I supposed to do? I got a 4, I got an 8, I got a 7. You got to try to think of a 3-way common denominator. I guess you don't have to do that. But, you know, you can say, well, you know, the 4 and the 8, that works pretty well. I can turn the 4 into the 8. But then if I use, what, the 4 and the 7 or the 8 and the 7, not very nice. You can look at the y's, you can look at the x's. My attention is drawn to the x's, actually, because I know I can triple the 3x to make a 9x, and I can double the 3x to make a 6x. So I'm thinking it'll be pretty easy to get rid of x terms, actually. So that's going to be my strategy. So I'm going to say extract 2 by 2 by eliminating x terms. That's my goal here. So pick 2 equations, any 2 equations. Maybe I'll play with the first 2. So this is a 9, this is a 3. It'd be nice to turn that 3 into a negative 9. How would you do that? You would have to multiply negative 3 times equation 2 in order to make that a negative 9. And then I would just add equation 1 to that. So that's my instructions to myself here. Now I'm going to follow the instructions. So negative 3 times equation 2 looks like this. I'm looking at this equation. I'm multiplying everything by negative 3. I'm getting negative 9x, negative 15y, plus 24z equals negative 3 times 91, 273. Okay, cool. And then I'm going to add, okay, so that's negative 3. Sheesh. That's negative 3 times equation 2 right there. Now I'm adding equation 1 as is, which means I'm just reading across here and copying it. 9x minus 2y plus 4z equals 31. Okay, so I got to add two equations together if I'm going to make something go away. So the nice thing is I made the negative 9x and a plus 9x. The x's go away, leaving me negative 17y plus 28z equals, and this will be a negative, what is that, 242 or something? Okay, cool. I'm going to give that a name. I'm going to call that equation 4 because I need to save that for later. This equation doesn't have any x's in it. That's going to be useful in a minute. Now, I have to do a different pair of equations. So not equation 1 and 2, but a different pair. How about equations 2 and 3? Let's play with those two. What I can do is I can take this 3x and make it into a negative 6x, and then it'll cancel this when I add. So that's what I'll do here. So I'm going to take my instructions to myself. I'm taking a negative 2 times equation 2, and I'm going to add equation 3 to it. Okay. So first, I'm just doing this part. Negative 2 times equation 2. So reading across here, multiplying everybody by negative 2. I'll have a negative 6x and a negative 10y and a positive 16z equals a negative 2 times 91, 182. Okay, so that's negative 2 times equation 2. Now I'm going to take equation 3 as is. So I'm just reading right across there and copying it. Whoa. 6x minus 7y plus 7z. That equals a negative 35. Okay, I'm ready to add these two equations together. So negative 6x plus 6x, poof, I got a negative 17y. Here I've got a 23 times z. And here I'll have to add 82, 182 and 35. What the heck is that? 217, I want to say. Yeah, negative 217. I'll call that my equation 5. Okay, we've just extracted a 2 by 2. If you want, you can put these two right next to each other. So equation 4 looks like this. Negative 17y plus 28z equals negative 242. And equation 5 looks like this. Negative 17y plus 23z equals negative 217. Cool. So now what we want to do is solve this 2 by 2 system. Looks like the y's are kind of begging us to do something here. So I think what I'll do is I'll just take a negative 1 times my equation 5, and I'll add my equation 4 to it. That's my plan. So a negative 1 all the way across here would give me a positive 17y, a negative 23z equals a positive 217. Okay, that's this part. Now take equation 4 as is. So I'm looking across at this now. Negative 17y plus 28z equals a negative 242. I'm ready to add these equations. Y goes poof. 5 times z equals, what is this now? Counting 17 to 42, 27, 37, oh, it's a 25. Cool. So it's a negative 25. Divide both sides by 5, and I love it when we get these nice answers, right? So z equals negative 5. Woohoo, we're making progress here. Now, let's get a different color. Let's go back and get y, right? So remember, these equations have x and y, so, or excuse me, have y and z. So once I have z, I can get y. So I'll just plug this into, I don't know, maybe just plug it into equation 5. Doesn't really matter. Get the same answer either way. Try it if you don't believe me. But anyway, negative 17y plus 23 times z, but z is negative 5, equals a negative 217. So that's telling me negative 17y. This would become a negative 115 equals a negative 217. So if I add that 115 on both sides, I think I'll have a 102, won't I? A negative 102. Cool. And then you divide both sides by the negative 17. And it turns out, if you multiply 17 by 6, you will get 102. So we've got the answer of y equals 6. 2 down, 1 to go. 1 to go. Now I'll put these into equation. Well, you have to go back to one of the originals now. They're the ones that have all three of them. And I'll just choose equation 1. Let me copy it here so I don't mix myself up too much. I got 9x minus 2y plus 4z equals 31. That's equation 1. So I'm plugging in, I don't have x, so 9x minus 2 times. I'm plugging in y equals 6 plus 4 times. I'm plugging in z equals negative 5. That equals 31. We almost have x. 9x minus 12 minus 20 equals 31. So 9x, what would that be? Minus 32 equals 31. Add 32 to both sides. 9x equals 63. Divide both sides by 9. X is a nice 7. So this is pretty good. So the solution here, x is 7, y is 6, z is negative 5. Cool. Now if I'm going fast, remember you can always, on YouTube, you can hit the settings button on the lower right and you can say play at half speed, play at 0.75 speed, stuff like that. Of course, pausing and rewinding is always possible. But there, we solved another 3x3. So again, these are 3 planes in 3D space somehow. And it turns out there is one point, that point, where all 3 of these planes cross. Cool. It'd be cool to get a 3D grapher somehow. Well, now, this one's not going to be quite so nice. I'm doing this one because I would like you, remember I recommended this calculator, and if you have this calculator now, you're going to say, oh cool, I get to use it, because I'm going to show you part of its power, just part of its power. By the way, there is an introductory video to this calculator. It shows you basically how to play with the fraction button and play with fractions and stuff on the Casio FX300. So I'll post that video right before this one if you want to take a look at that one. That one you might want to play at like 1.5 speed, but anyway. Or maybe you won't need that. Maybe this lesson will be good enough for you. But the thing is, the numbers are going to get funky, but I want to show you how the calculator helps. So begin by calling this equation 1, equation 2, equation 3. Now looking at the z's, I got a 36 and 18. Well, you've doubled the 18 to get a 36, but that 27 doesn't look too friendly. The y's really don't look, the x's don't look so bad, I suppose. Let's play with the x's. What do you say? What do you say? So I'm going to, maybe I'll look at these two, because I can turn the 6 and the 9 both into 18s and then make them go away. So I think what I'll do is I'll maybe take equation 2, make that into a negative 18x. So this is a negative 3 times equation 2. And then I'll add 2 times equation 1. That's my plan. So looking across here at equation 2 and multiplying everything by negative 3, I will have negative 18x, negative 63y, negative 81z equals positive 321. Wow. Okay, now that I got that done, I have to do 2 times equation 1. So reading across the top equation and doubling everything, 2 times 9, I have a positive 18x, minus a 60y. 36 times 2 is a 72z, and then double the negative 212, I get a negative, 424. Cool. Now I can add these equations. Sometimes I put like a little plus here. Now I'm going to add these 2 equations together, and of course the x's go poof. Cool. We're making progress. A negative 63 and a negative 60 makes a negative 123y. Let's see, negative 81, positive 72. Well, if you count from 72 to 81, that's a 9. So that's a negative 9z. And then you have to add these up. 321 minus 424, grab out your calculator if you like, comes out to a negative 103. I really hope I don't make a dumb mistake while I'm doing this. Anyway, x is gone, there's a y and a z. I'm going to call that my 4th equation. Woo! Now, I played with the top two equations. I need to play with a different two equations. I'm thinking maybe the bottom two equations, because I can take that 6x and I could turn that into a negative 30x if I multiply by negative 5. So my idea is take negative 5 times equation 2 and then add equation 3 as is. So that'll look like this. So reading across equation 2 here, but multiplying everything by negative 5. That's a negative 30x. Negative 5 times 21, that's a negative 105y. Negative 5 times 27, that's a negative 135z. Negative 5 times negative 107, that's a 535 positive. The numbers are getting big enough to want to grab out a calculator, right? Okay, so anyway, and then equation 3 as is. So bottom equation as is. 30x plus 24y minus 18z equals a 59. Okay, we're ready to add those two equations. Once more, the x's go poof. That was our goal. So I got a negative, what the heck is this? 81y. And then here I got a negative 153z. And then over here I got 535 plus 59 is what now? 594. Okay, there's my equation 5. I am now going to put these two equations next to each other so it's easier to kind of look at them, try to figure out what I want to make go away next. I've basically just succeeded in extracting the 2x2 system, right? Wow, look at these two things. So that's equation 4, that's equation 5. That's a 94, by the way. Let's try to make it look like a 94. Let's like really try to make it look like a 594. Come on, you. Come on, you. 594. There. Okay. Well, this is where a calculator comes in handy. One thing you might do, just to see if you're lucky, take 153, divide it by 9, and see if it comes out even, because if it does, that's awesome. That would be, you know what? It's awesome. It comes out to 17. Woohoo! If that didn't work, you know what I could do? I could take the 153 and double it, see if 9 goes into that, triple it, see if 9 goes into that, and if I'm not having much luck, I could try to play similar games with the 123. But anyway, you got to find a common denominator. It turns out 153. 9 goes into 153. That's awesome. So what I'm going to do then is I'm going to take, it was a 17, right? So I'm going to take 17. Let's make it a negative 17 times equation 4 and add equation 5. So, negative 17 times negative 123. Grab out your calculator. It comes out to a positive 2091y. Cool. Negative 17 times the negative 9 comes out to a positive 153z. Negative 17 times a negative 103 comes out to a 1751. Okay. Now, equation 5 as is. So negative 81y minus 153z equals 594. Yeah, these are nice numbers. Nice and big, I mean. Now we're ready to add these two equations together. 2091 take away 81 is 2010y. The z's go away. You take the 1751, you add the 594, push a few buttons, you get a 2345. Okie dokie. Now you know what you'd have to do here, right? You'd have to divide both sides by the 2010. And it would be time to reduce. But if you have your Casio FX300 ES, then you smile, you say, oh my gosh, this is so easy. All you got to do is type this in, 2345 divided by 2010, and your Casio calculator will tell you, and it will even make it a fraction under its default settings. 7/6. Y is equal to the nice reduced fraction 7/6. Now you may have heard me saying in college algebra we like fractions. Fractions they keep exactitude going, which is nice. Plus, we often have tops and bottoms to our formulas and equations and stuff. You might as well just let your number have tops and bottoms. Besides, who wants to schlep around a 1.1666666? You don't want to schlep around weird decimals like that forever. 7/6, it's great. So you could, of course, have tried to reduce this by hand and say, I guess I can cancel 5s, and keep going forever for a long time and end up at 7/6. Or if you get this calculator, and I'm sure there's some other calculators that'll work for you too, but this one is the handy dandiest one I've ever played with, so that's why I recommend it. So let me try to make that a little clearer there, because this is actually an important point. 300, and the most important part, besides Casio, is ES. Casio FX300 ES. Oh, wonderful, wonderful calculator. So, now that we got Y, what do you say we go back and get Z? Scroll up a little bit. So I'm going to plug Y equals 7/6 into equation, I'm going to choose equation 4. Doesn't particularly matter, especially when you get that calculator in your hand. So I got negative 123y, it says. Negative 123y, and y is 7/6 minus 9z is equal to negative 103. Now, if you get your Casio out, you just type this, negative 123 times 7 divided by 6. And it will tell you that this eventually reduces to negative 287 over 2. That's what that is, negative 287 over 2. Of course, we could have done that ourselves. We could have said, let's see, I could cancel 3's. 3 goes into 6 twice. 3 goes into this 41 times. And then you take the 41 times the 7 on top to get the 287. You get the 1 times 2 on the bottom to get the 2, and it's negative. Yeah. But what I'm saying is, if you got the calculator, it's going to make your life a little happier. Your homework life will be a little happier. And by the way, the next lesson, you're really going to want to have this calculator. Just trust me. If you think it's good now, you're going to really want it in the next lesson. And then you're going to want it again when we're simplifying radicals. It's a good calculator. Trust me on this one. So let's get back to finishing this up. So I multiplied the 123 times the 7/6. I got this, minus 9z equals. Now this negative 103, I like to do this. I like to say, wow, that's like a 1 over 3 over 1. I can call this a negative 206 over 2. That way I've got my common denominator all set up. So negative 9z is equal to, you're just adding the 287 on both sides. I think you're getting an 81 over 2, aren't you, or something? Yeah, you're getting an 81 over 2. And then lastly, divide both sides by negative 9. That would look like this. Remember, to divide by 9 basically means put a 9 on the bottom. It means multiply by the reciprocal, multiply by 1/9. Here, you can use the calculator if you want, or you can just, oops, not a 2. Or you can cross cancel. 9 goes into 81 9 times. And so we've got a negative 9/2. That's our z. Now if you want to practice with the calculator, you could actually enter 81 divided by 2. That's what this is. And then say, oh, divide it by negative 9, please, because we have to divide both sides by negative 9. It will tell you this. Go ahead and try it. You'll love it. By the way, some people always say, hey, how come the calculator is always giving me fractions? What if I want the decimal? If you want the decimal, there's a special button that says SD. It's kind of on the right, kind of in the middle on the right somewhere. You'll see it. It just has an SD on it, and the SD will turn that into a negative 4.5. But who wants the decimal? We want the fractions. Those are cool. So we got this y, we got the z. Now we need the x. Go back to one of the original equations. Doesn't particularly matter which one. I think I'll take this one. So equation into equation 2. Plug y and z into equation 2. So equation 2 is 6x plus 21y, 6x plus 21y plus what now? 27z equals negative 107. Double check. Yep. That's our equation 2. I don't know what x is. I do know what y is. Y is a 7/6 plus 27. I do know what z is. Z is a negative 9/2 equals a negative 107. 6x plus Now you can enter this as 21 times 7 divided by 6, and your Casio will tell you that it's a 49 halves. I just love that. Here, you know it's going to be negative, right, because it's positive times negative, and you can just take a 27 times 9 divided by 2. Casio will give you the fraction for you, and the fraction will be, what did I get? 243 over 2. And then you don't necessarily need to put that over 2 if you don't want to. Because what you could literally do with your Casio is you could take that negative 107 and say, well, I have to subtract this on both sides. So negative 49 divided by 2 is how you could enter that. And then I have to add this on both sides. So plus 243 divided by 2. And then when you hit your equals, it should tell you 6x equals, what do I get? I think I got a negative 10. All that to get a negative 10. Divide both sides by 6. Okay, we don't have to do everything with a calculator, do we? So a negative 10 over 6 means cancel 2's. Negative 5/3. There! So our solution, x is negative 5/3. Y is, what was y? 7/6. Z is negative 9 halves. So there will be some of your homework problems where you're going to get answers that are all nice and fractiony like this. Some of them won't be so bad. You might be able to just do your fractions directly. Some of them might get a little intense, and you might want to grab out that special calculator. Or maybe you've got a calculator that's just as good, though I doubt it. I haven't seen one yet. I haven't had a student show me a calculator that was as good. So they all try, but I haven't seen one as good yet. So it's 15 bucks at the bookstore if you want to get one. It might be a little cheaper elsewhere. Now these last two, these are going to be fast because, I mean, it says right here, trouble. With these, you run into trouble. Now, what I'm going to do here is I'm going to hit the trouble right away because I know how to hit the trouble right away. I'm going to take negative 2 times equation 1 and add equation 3 to it. My idea was to make this a negative 4x and that a positive 4x, and the x's will go away. Watch what happens. So a negative 2 across here is negative 4x minus 6y minus 2z equals negative 10. Equation 3 as is, 4x plus 6y plus 2z equals 6. The x's cancel, the y's cancel, the z's cancel. The left side is 0. On the right you get a negative 4. Now when we were playing with 2x2 systems, we would have said, oh, parallel lines, no solution. We're not going to say that here. We don't know. Remember, these are not lines, they're planes. And it's not necessarily the case that the planes are parallel. So there's a catch-all term that we can use. When you have a 3x3 or higher order system, 4x4, 5x5, just call it a degenerate system. Don't worry about trying to distinguish, you know, no solution versus, you know, same line, same plane. No, don't just say degenerate system. So if you have this kind of a thing, a contradiction, 0 equals negative 4, no, it doesn't. It can't be solved. It's a degenerate system. Similarly, if I take, well, I'm going to do, oops, that's equation 3. I'm going to do kind of the same thing here. I'm going to take negative 2 times equation 1, and I'm going to add equation 3 because I'm trying to make x's go away here. So negative 2 across the top, negative 4x minus 6y minus 2z equals negative 10. Equation 3, the bottom one, as is, 4x plus 6y plus 2z equals 10. And you see a slightly different thing happens here. X's go away, y's go away, z's go away, left side is 0, right side is 0. Okay, that's a different thing, right? This is not a contradiction. This is always true. With 2x2 systems, we would have said it's the same line, but it doesn't have to be the case that we have the same plane. In this case, I think we do, but don't worry about it. Just no matter what, if anything goes wrong, if anything goes wrong like this when you're doing 3x3s, the answer is degenerate system in both cases, okay? So that's the good news. You write the same thing in either case, degenerate system. There's a cool website, and I think I'm going to put a link up that you can like enter this, and it'll kind of show you a picture of the plane. You can enter this. You could try to look and see what's happening. There's all kinds of things that can go wrong. You could have a plane planes that kind of go like this, right? Where do they all this is like I'm looking down the edges of pieces of paper here. There's no one spot where they all intersect. I mean, it's a problem. It's a degenerate system. You could have, of course, 3 parallel planes. There's not going to be a solution there. There's all kinds of situations where you're not going to have solutions. So rather than distinguish them all, just in all cases, just say degenerate system. Okay, trying to make things a little easier there. Okay, cool. 3 by 3s. They're what's for dinner.